Mr. Beacon podcast is sponsored by Williot, scaling IoT with battery-free Bluetooth.
Welcome to the Mr. Beacon podcast. I hope everyone is doing well. Gosh, it's been months we've been going through this COVID nightmare, but one of the wonderful things is that we have the technology that we're using today to talk to interesting people around the world. I don't think we've ever spoken to a guest from Norway, and I know we've never delved into ultrasound, which is a major omission and one that I'm looking forward to rectifying. And we're doing it with Wilfred Boy, who is the CTO of Forkbeard. Wilfred, welcome to the show.
Thank you, Steve. It's an honor.
So you were part of another company that was dealing with ultrasound before Forkbeard. How old is Forkbeard, and what's the relationship between Forkbeard and this other company?
Yeah, so Forkbeard is actually quite a new company. We started it, I think, in January 2019. So it's just over 1 year and 8 months old. But we started actually with 15 people. And those came out of another company that was doing ultrasound-based indoor positioning. The company's called Zonal. And we're still sharing office with them, but it's two separate companies now. And Zonal basically has been developing indoor positioning solutions for use primarily in healthcare. So it's basically an ultrasonic technology where you have transmitters in the infrastructure, and it's tag based. So basically we have tags that receive ultrasound and that can then be used to do positioning of people and equipment. And the key strength is this high resolution zonal capability. So the fact that you can actually tell whether a patient is in a bed and whether equipment can be associated with the patient and so on.
And this is Zonal that you're talking about.
Yeah,
here.
This is Zonal. Yeah.
Okay,
Yeah.
so you have the tags, the receivers, the kind of the infrastructure is broadcasting ultrasound.
Correct. Yeah. And one of the things that we always dreamt about in that company is to do proper 3D positioning. So rather than a zonal-based system, which is what Zonal has today, and which is very suitable for in the healthcare business. The aim was to have a system that basically, where you can do software zoning. So fundamentally accurate 3D positioning, and then in software you can define your zones and set up your rules and so on. Whereby you can actually decouple. The big thing there is that allows you to decouple your infrastructure from your use case. Which, of course, if you want to scale something is really important. The fact that you can basically set up an infrastructure and say, it's like Wi-Fi, now you have communication, now you have positioning and throughout your building, and then you can basically use it for whatever you would like to use it for. So it needs to be accurate, low latency, and persuasive in the whole building. So that's basically what we set out to do in Forkbeard. And one of the main other realizations was that let's do it using smartphones. So let's not go the tech route, but instead use a smartphone and basically app enable the positioning.
Okay, so one of the differences is Forkbeard has the smartphone component. And in this case, the devices that so do you just sell one kind of device, a transmitter? Or?
Yeah, at the moment we've got one device which we call the Ultra Beacon for ultrasound beacon,
yes.
And it's really a combined Bluetooth beacon and ultrasound beacon.
So how large are these devices?
They're actually quite small. They're about the size of a Apple TV box.
Okay.
And the size is really dictated by the 4 AA batteries that we use to power it.
Okay.
And it's quite interesting because we basically, based on the experience we have at Zonal, we had sort of like a target for battery life, and we basically said it needs to be more than at least 3 years, but preferably 5 to 7 years. So it's sort of like a set and forget. And with the help of new releases from chip manufacturers, we were able to achieve 10 years of battery life on 4 AAs. And that's standard. That's not just sort of like a particular configuration, that's any configuration. So that was a really major achievement.
Yeah, 10 years is good, running off batteries, so people don't need to worry about wiring and so forth. So, typically, how many of these do you need to achieve a given level of location fidelity?
Yeah, since it's a solution that basically wants to achieve 3D, the minimum quantity that you have to be within reach of is 3 at the moment. So that sets a sort of like a minimum density of devices. That depends a lot on how fragmented the environment is. But we basically, as a sort of like a rule of thumb, we're saying around 1 for every 30 square meters.
Okay.
The design guideline.
That seems pretty good.
It's pretty good. Yeah.
And if I have 1 per 30 square meters, then what kind of location accuracy am I getting?
It's about a feet of accuracy in the 2 XY dimensions, and then it's a little worse in the Z dimension. It's about probably 2 feet in the Z dimension.
Okay. And I guess, when does that matter? I mean, if you're tracking a phone, wouldn't seem like that matters too much, the Z dimension.
No.
Right.
No, I mean, it's sort of like if you get into atriums and that sort of stuff, it's interesting to have a good Z dimension, and then 2 feet is more than adequate to be able to do floor separation.
So, positioning this against other technologies, just bare Bluetooth, you're much better. You're probably slightly better than angle of arrival. Maybe the angle of arrival for Bluetooth guys would argue with that, but it seems like you're a bit better, and you're not quite as good as ultra wideband. Is that a fair characterization of where you sit in the pantheon?
Yeah, I think so.
Location technologies. Okay.
Yeah, and then of course we have the advantage that it's a fully battery-powered infrastructure. So if you look at the cost of installation, then it's quite dramatically different. And in itself, it's a very cheap device. It's not like an expensive unit to manufacture at all. It's essentially a Bluetooth beacon with ultrasound capabilities bolted on.
So for budgetary purposes, what should people budget for if they want to buy 100 of these units? What should they budget for as a per unit price?
So we typically try to price by square meter.
Oh, okay.
So we're sort of like targeting a sort of like a couple of dollars per square meter as our pricing for installation, which is really quite good. Because if you look at a supermarket, an average size supermarket is about 1,000 square meters. So in principle, you should be able to equip that with our solution for a couple of $1,000.
Couple of $1,000 for roughly how many units?
That's probably about so that would be 1,000 square meters. If you divide it by 30, that would be 30 to 40 units.
Okay. That is pretty low cost.
Yeah.
And the bane of Bluetooth existence is metal and that sort of thing. Presumably you're less concerned about that, although how much, I mean, we think about line of sight. What role does line of sound have for your product?
That's a very good question, and it's one of the reasons why we actually went for ultrasound in the first place. Because of course, if you look at a pressure wave interacting with the environment, it's actually extremely predictable compared to an RF wave. So if you have an RF wave, especially at 2.4 gigahertz, if it impacts on a particular piece of material, you've got all sorts of mechanisms going on. You've got basically backscattering, you've got absorption, you've got backscattering a couple of 10 centimeters back. So I think one of the fundamental problems with RF is that it's very difficult to basically get an idea of what your line of sight is, because even if you could do path decomposition, it would be extremely difficult to say, well, this is the line of sight. And that's one of the biggest.
Briefly use the term backscattering. Not everyone will be familiar with that.
Right. Yeah. So a wave basically impacting on a surface, you can basically have a couple of fundamental interactions. And scattering is just that you lose the phase information, and the wave is coming back at you with an unknown phase in a way.
Right.
And one of the really nice things with ultrasound is that you have none of that. So when basically a wave hits, an ultrasonic wave, a pressure wave hits a surface, it's most of the time perfect reflection. And what happens at perfect reflection is that all the information is basically intact.
Mm-hmm.
So
you do have another path, do you? If you're
So, but what we found out, and we've done a lot of patenting on this, and if people are interested, they should look it up. But it's a method of basically path decomposition, where you can basically, when I have a transmitter in a typical building, and it's basically sending a signal out, and I'm within a couple of meters. We typically find 6-7 paths. We can decompose all the paths. And use, in fact, all the paths in the positioning.
So actually these multiple paths through this path decompositioning, they help rather than hinder?
Yeah. So future versions, we could probably, you could be looking at doing positioning only using a single transmitter in the room.
Okay.
By using the path decomposition.
So it sounds like the primary use case that you're serving here with Forkbeard is IPS, indoor positioning systems, although presumably this works outdoors as well.
Yeah, no, it is firmly focused on indoor positioning. So the whole mission of the company is to basically take the GPS revolution indoors. We don't want to take GPS indoors, but we want to basically enable the world to fill in the blanks in a way indoors.
Yes.
And of course, it needs to be better than GPS in many ways indoors, because your dimensions are shrunk and you're interested in more resolution than you might be outdoors. So that's the aim of the company.
Very good. And this presumably then relies on you having an app. I mean, what's the point of doing it if you don't have an app? So you have a Forkbeard aware app that has some APIs that are presumably listening to the microphone. How do you deal with getting the apps in because presumably to do this, the app needs to be in the foreground. You can't have, or can you? Can you have an app that's listening to sound in the background, or do they have to be?
We've got some good news there. The app is on the App Store and on Play Store, so people can download it. The challenge now is to find a venue that supports it. You have to travel to Norway to find that.
Good come to Norway. Okay.
Yeah. So we've got to install a couple of supermarkets and offices. But the really interesting thing is that this also works in the background, and you can actually have the phone in your pocket and get the same quality of positioning as you would have when you have the app in the background.
Amazing. But so what happens if I've rebooted my phone? It can still work in the background?
No. I mean, it does run as a normal app, but we basically because we don't because basically sound is enabled in the background because of VoIP applications.
Okay.
It allows you to basically use sound in the background in both iOS and Android.
And are there permissions that I have to opt into to allow this to happen? Yeah. So you're not running afoul of the privacy thing. Someone has to say yes, it's okay for this to do. So I thought I saw something about Bluetooth in what you did as well. Do you combine Bluetooth in any way, or was I just misreading it?
Yeah, absolutely. Yeah. So the concept is so one of the great things about ultrasound is that you can do very reliable path decomposition, and you can do very reliable distance measuring. But the bandwidth of it isn't great. So you have very limited bandwidth. On the phone is really limited. I mean, basically our signal spectrum is it has to be all above 20 kilohertz, and then the microphones start to drop around 22 kilohertz. So you effectively only have a kilohertz or so to play with. So the amount of information you can send from a single beacon is very limited. So what we do is we actually use a combination of Bluetooth and ultrasound to give enough uniqueness to a beacon. And in addition, you also can basically use some of the lightning and thunder principles. So the fact that an RF wave is traveling much faster than a pressure wave. So that allows you to do distance measurements.
Okay, so in this case, the Bluetooth is the lightning, and we see the lightning before we hear the thunder, and then obviously your ultrasound is the thunder, although we don't hear it. Can dogs hear what you're transmitting?
Yeah, it's even some kids at a very low age are actually capable of hearing above 20 kilohertz, but I think it drops off within the first 18 months or so. But given our experience in the field, what we did is that not only is it sort of like encoded in a very special way, so it doesn't create lots of harmonics, but it's also really low level. So in most of the time, you can't actually, it's actually in the noise floor. It's a little bit like the ultra wideband in that the signal level is extremely low.
Okay, so dogs won't start barking, babies won't start crying. There's no.
So you're looking at SPL levels of 60 dB or less. So and 60 dB, that's I think if you drive in a car, you're already up in the sort of 70, 80 dBs. 60 dB is sort of like office level.
Fascinating. So what about kind of the time dimension to this? Am I getting, can you kind of quantify the accuracy over time? If I'm like sprinting through the shopping mall, will you, how many times will you see me versus if an old person is making their way slowly?
Yeah, it's a very good question. And the good news is that we typically have between 5 and 10 updates per second.
Huh?
And the other nice thing is that there is something called the Doppler effect that most people might be familiar with. When you're passing the siren, you get this shift in frequency.
Yes.
And what that allows you to do is it allows you to measure velocity at the same time.
Ah.
Not only do we have distance, but we also have velocity of the phone. And not only do we have the velocity along the path, but we have the velocity on all the paths.
So this is fascinating. So maybe if I have some kind of point of sale promotion, you can see people not only passing it, but people slowing down to look at it. You can get the impact of engagement because, okay, I put the sign by the front door. Yeah, everyone's going to walk past the sign. Does that mean the sign is super successful, or does it just mean that people want to get through the front door? But if you can say, we had some kind, it's sort of almost like dwell time, only kind of something a little more subtle that you could potentially deliver. Is that, or am I just...
Yeah, so you can basically have a sense of direction instantaneously, which is also really interesting in positioning, of course. So you can basically have a pass through a door, and you can basically tell what the direction of the pass through is without having to have multiple position events.
Okay.
Which is also really interesting. Plus, of course, if you're into sort of like Kalman filtering, which we are, then having the state and the derivative of the state, so having the position and the velocity, really helps in getting higher accuracy.
So you said something about filtering, and I missed.
Yeah, Kalman filtering. So this idea that you have a state estimate where you have multiple observations that are related in some way that you can easily model. And of course here it's very clear. You have basically a range, and you have the derivative of the range. So having both velocity and distance between the smartphone and the transmitter allows you to improve the accuracy dramatically.
So how can I consume all this information? It seems like there's potentially a lot there. How do I get it? What sort of apps are you supporting and enabling?
So the principle is that we're not an app company. We're basically delivering the tools for others to build apps. So what we have is an SDK. We have multiple SDKs. And those SDKs basically do all the heavy lifting. So what you actually get is an API which is very similar to GPS. So you have a start-stop and you have a position push. So you can basically subscribe to a position update in the app, and then basically every time we get a decent update. And you can also define some parameters. You say, I want a high resolution update, or I want very low resolution update. So it's very much like, basically what we did is we looked at the APIs that were available within the operating systems and said, this is what developers know. This is what we want to deliver to the developers. So our experience is that, people can basically get an app going within a day or so based on the SDK.
Brilliant. And how's that going in terms of app integration? Do you have demo apps? Are there other apps, partner apps that you've integrated with?
Yeah, so like I said, we have a Forkbeard Lyra app on the App Store and Android Play Store. And that basically just shows, it's a demo app. It just shows the capability of the solution. And then there are a couple of custom apps, which unfortunately I can't disclose at the moment because they're still sort of like in development phase. But some of them are, office type environments, and we have 2 supermarkets that have the installation in Norway. And there, the use cases are very advanced in that it's basically product. So it has a complete product database, and it has multi-point navigation to do your shopping in the supermarket. So you can basically, you can compose your favorite shopping list, and then it will actually show you the route in the supermarket. You can download a new recipe. And one of the big problems, of course, people have with new recipes is that there are new ingredients that they never find. So this is the idea behind the app, is that basically it's a very good way of getting people to be a little bit more adventurous in cooking.
Okay, very cool. And where do you, so it sounds like you basically give a GPS coordinate. So you're partnering with all of the mapping, you work with third-party partners that can give you a map. And
yeah, it can actually live directly on top of the Apple and Google Maps solutions. So basically what we also offer is an additional API, an SDK that allows you to live on top of a Google and Apple map with an additional layer. And then there's example code that allows you to then basically easily draw paths and that sort of stuff. So we also actually have a routing SDK.
I was going to ask you about that. So you can give people the fastest way to get to the cinnamon from the fruit part of the supermarket.
Yeah, and it's actually configuration-free routing, so you don't actually have to draw any paths in advance. So he actually uses the map of the store to automatically do the routing without having to specify paths before.
All right. The question I've got to ask is about the name. Can you? You're probably sick of telling this story, but
no.
You've got a very nice logo. I really like the logo. It sort of resonates from Bluetooth in that you've got letters in this kind of round thing that looks like a map pin. But where does the name come from?
So the name is interesting. We basically, of course, we were starting the company. We said, well, there's Bluetooth, and people associate Bluetooth with positioning these days. Although really, it's a communication technology. So we decided to go back in history and say, and Bluetooth, of course, in Scandinavia is very well known. Blåtand is a Viking king, one of the best known ones.
And what was exceptional about, if we're going to do the whole thing, then what was exceptional about Bluetooth as a king that he got given this association with a communication?
He was a smooth talker. He was very good at communication. Right. And now the best part of the story is, we started to think about, okay, historically, who was the person that really trumped Bluetooth? And it turned out to be his son.
Oh.
The name of his son is Forkbeard.
Okay.
And fortunately enough, he was a good navigator. He was the guy that basically invaded England, unfortunately.
All right. Okay. So
did some atrocious things there, so I don't want to talk more about that. I don't think you could have named a company, if it was possible, 50 years after his birth. I don't think it would have gone down that well. But with time, things fade, and it's an acceptable name now.
Yeah. Well, yeah, and appropriate given that you have some Bluetooth lineage in the makeup of your solution as well. Very good.
Yeah.
Well, this has been fascinating. Anything else that I should have asked you about that?
I think you did a tremendous job, Steve, in asking the right questions.
Well, we'll end up on a high note then. So, Wilfred Boy, CTO of Forkbeard, thanks very much for being on the Mr. Beacon show.
Thank you, Steve, for giving me the opportunity.
How should I pronounce your last name, Wilfred?
It's very simple. It's actually boy, like
Boy.
in boy. Yeah. So it's Frisian, which is very close to English.
Okay.
So it actually means boy in English. Yeah,
amazing. I'm so glad I asked you. Normally I have a go and massacre people's last names, so I would have been pronouncing the J. So
in Dutch they didn't have the Y on the keyboard, so it became IJ.
Oh, so that's your ancestry is
Frisian. So it's northern parts of the Netherlands.
Oh, fascinating.
Yeah.
So how did your family end up in Norway?
Oh, I moved to. I studied in first in the Netherlands, took a master's in the Netherlands, but then I moved to Cambridge, and that's where I met my wife, who's Norwegian.
I saw that you did your PhD there, didn't you?
Yeah. So it's a lot
what was that like?
Very nice. Yeah. It was very interesting. I was
hunting on the cam, all that sort of stuff.
Hunting on the cam, and really international environment. I was a fellow of Gonville Keys College, so I actually got a fellowship there, and dined with Stephen Hawking. Lived next door to Stephen Hawking, in fact. So yeah, lots of really interesting experiences.
I went to a polytechnic to do my computer science degree, and basically as a result of a misspent youth, at the time it wasn't a good place to study, but by accident it turned out to be a great course. It was just all the fundamentals, but that was purely by accident. At the time I had a girlfriend whose father was doing, I can't remember what he was, I think it may have been a PhD at Cambridge. And I remember going there and having to wear a tuxedo to have dinner and table service in these incredible halls. It was amazing.
Yeah. So as a fellow, you basically have free dining every evening, and it's they serve the best wines, and the food is phenomenal. And then you see the poor students sitting, just 2 meters away, and they get served, well, not the same quality of food. And of course, I was used to sitting there, so it was a very weird experience.
And was it different? I guess your experience was different. You were slightly older than the undergrad.
Yeah. So I started as a grad student. So I did a 3-year PhD, and at the end of the PhD I got this research fellowship, so I stayed on for another 2 years. So
did you ever sort of wish that you were the 18, 19-year-old having that experience, or was it better being able to savor it? You actually knew what a good wine was supposed to taste like.
I think it's very difficult to beat Dutch student life. So it's fantastic because you have an enormous amount of freedom, and at the same time you have this rich tradition of quirky student behavior in Holland. So there's a lot more freedom than you would ever had on a UK university. So I actually took 6 years to take my master's, and that was time well spent.
Excellent. Very good. Yeah. Well, as you you may or may not know, I don't know if you've ever watched any of the past episodes, but we have this tradition of asking people about their music tastes. And basically the construct is, what 3 songs would you take on a trip to Mars? Sounds like this is new to you, so I'll give you a little time to think about it. But first question, I guess, is music important to you? Was music part of your life when you were a student, or as you?
Yeah, absolutely. Now? Yeah, although a lot less now than it used to be. But yeah, I mean, sort of, I guess I've quite a settled music taste now, which I'm sort of like infecting my kids with.
Really? What's that? How would you characterize it?
Oh, it's probably quite. It's fairly mainstream, I would say. It's it's the usual stuff from having been born in the '70s. So it's Hotel California, Steely Dan.
Yeah.
Later added Katie Malua, and that's sort of like quite straightforward, nice, easy listening. A little bit more jazz. Jazz is also quite interesting. So,
very similar to my own. So if you had to pick 3 songs, what? This
I
is
was just saying,
spontaneous. You don't have much time.
I guess the Night Fly. Is that mentioned? Hotel California, I would say, is probably somewhere up there.
Yeah.
The third song would be more difficult. I guess could be "Killing Me Softly."
Okay. Great songs. Wonderful. Thanks very much.